We are about to begin our trip to Moon. I request everyone to kindly be seated. Humble request to kindly be seated so that we can begin with the third plenary talk of ESTIC 2025. So I hope after a dose of caffeine, we all have returned with high spirits, something what ESTIC is aiming for. And with that, I will request our session coordinator, Dr. Rashmi, to kindly come on the dais and commence the session.
Distinguished delegates, speakers, ladies and gentlemen, namaskar and good evening. It is my privilege and honor to welcome you all to the plenary session 3 on space exploration and exploration of lunar resources with Dr. Jean-Yves Le Gall, former president of French Space Agency, as plenary speaker, and Shri A. Rajarajan, Director Vikram Sarabhai Space Center, Indian Space Research Organization, as session chair. It has been an exciting day since morning. You all must agree with this. ESTIC has given us all the opportunity to listen to the vision of our Honorable Prime Minister Narendra Modi ji. Under his visionary leadership, India has got worldwide recognition in space sector. Space sector is now open to startups, entrepreneurs, and young minds. This is the last session today, but I believe that the spirit of knowledge diffusion, propagation, and sharing must continue. To take this forward, I would like to invite the session chair, Shri A. Rajarajan, who is a distinguished scientist and director of Vikram Sarabhai Space Center, ISRO. He was earlier a director of Satish Dhawan Space Center, Shri Harikota, that launched the India's heaviest communication satellite yesterday, as mentioned by our Honorable Minister of Science and Technology in the inaugural session. Shri Rajarajan has contributed immensely towards technology leadership at ISRO in various capacities and roles that have been transformative for making India self-reliant. In Hindi, we say Atmanirbhar in the field of space technology. With this, I would request the session chair to take the proceedings forward. Shri A. Rajarajan.
Thank you. First of all, thank you for the opportunity to chair this very interesting topic and session, the way forward in exploiting the lunar resources. And we have a very eminent speaker for this in this session. As we have the person as a last session today, this talk is going to be given by none other than Jean-Yves Le Gall, very famous person, a well-known personality in space arena, who has led many important events in the European Space Agency's activities, and we at ISRO had a wonderful interactions in many times at different levels. As we all know, he has more than 40 years of devoted work in shaping and leading the space programs in France, Europe, and around the world. And he continues to contribute in several international bodies, working in the area of space and high-tech area. To just put it on the record, from 2013 to 2021, he was the president of French Space Agency CNES, the chair of the Council of the European Space Agencies, and also the chairman of the administrative board of European GNSS agency, that call it as GSA. And he was also the president of International Astronomical Federation, where we are immensely benefited when he has taken it to many places. And that is one of the wonderful contributions which is not well noted, but because he has so many contributions as Kenneth and developing many technologies. Also, he has in the earlier avatar, he has held several posts in the French National Scientific Research in CNRS, and at several French ministries his contributions are immense. And at No Space, Starsem, and Arianespace to be known. And in Arianespace, he was the CEO from 2001 to 2013. That is the type of leadership that he has brought in from 2001 to 2021. 20 years of leadership in various critical areas, shaping the way forward. As we all know, he has also got many awards and the French Academy of Technologies, and some of the awards that he got is the Astronautics Prize from the French Association, AAAF. He was named the Via Satellite Magazine's 2005 Satellite Executive of the Year, the Lifetime Achievement Award in 2007 from Asia Pacific Satellite Communication, and he was inducted into the Hall of Fame of Society of Satellite Professionals in 2011, and awarded the prestigious Icarus Prize from the French Association of Professional Aerospace Agencies, among few. And he is also one of the laureate, distinguished with the Laureate Award from the Aviation Week and Space Technology Magazine, and the Caltech presented him with the International Von Karman Wing Award in 2021. And he also received the IAF Excellence in the International Cooperation Award. And in 2024, he was awarded the International Cooperation Award from the AIAA. So now he is holding also the rank of the Commander of the Legion of Honor and Commander of the National Order of Merit. And he has also been the Order of Friendship by the Russian Federation, the Order of the Rising Sun, Gold and Silver Stars by the Government of Japan, and the Chinese Government's Friendship Award. And also a doctorate in the ISRO Institute of Technology, among many others, some few I noted. So we now will request him to present what is his thought process in exploring the way forward in taking care of the lunar resources. Welcome, Dr. John.
So, thank you, Mr. Chairman, and good afternoon. First of all, I want to tell you how I am happy to be back to India, because, as it has been said, I consider that I have a long-standing relationship with India. Starting was when I was in charge of international relations in CNES, the French Space Agency. After that, I've been at the head of Arianespace during 12 years, and we launched many Indian satellites. And when I was in CNES, my last active position, we developed a number of satellites with ISRO, and I am very pleased to see here a lot of friends, because when you work in the field of space, you become friends, because it's so tough, so difficult, and I have souvenirs with my friend Mr. Kiran Kumar in French Guiana launching satellites or launching satellites here in India. And so I am very, very pleased to be here today and to have been invited to speak about what is, in my opinion, the next chapter in space exploration. But before that, I would like just to remind you that I had the privilege to welcome the Prime Minister, Mr. Modi, in Toulouse, in the Toulouse Space Center of CNES a few years ago during a state visit in France. And the Prime Minister of India spent some hours with me in Toulouse, and I've been very, very impressed. This time I have the souvenir of this visit, which has been reinforced by what I heard this morning. But I said to myself, India is very lucky to have such a leader, because Mr. Modi asked me a lot of questions, and a lot of very accurate questions, and I remember that one question I didn't know what to answer, so this is the kind of souvenir you have for the lifetime. But he was very, very interested in space, and of course interested in the cooperation between France at this time, Europe, and India. And since this visit, of course, we developed a lot of new projects dealing with questions related to sovereignty, to climate change, or to exploration. And so today, when I was invited to speak in front of you, the organizers told me you can speak about what you want. This is not so frequent, because in general people ask you to speak about specific topics that in general you don't know. But here I could speak about what I want, and so I would like to give you my thoughts on human space exploration, and what in my mind marks the next chapter in space exploration, that is exploiting lunar resources. All of us who are interested in space, we know the key dates of exploration of space. Of course, space started in 1957, on the 4th of October, with the launch of the first Sputnik satellite. After that, on the 12th of April 1961, we had the flight of first human in space, Yuri Gagarin, and in July 69, just 8 years later, the lunar landing of the Apollo missions, and in parallel, of course, we had launches, the first launches of Europe, of India, and other countries. But now we are in a new situation. In fact, we have satellites, we have launchers, we had, and I will come back on this point, astronauts which are in orbit, and what is the next step? And I would like to start to speak a little bit about the International Space Station. All of you know the station. It has been deployed in the beginning of the years 2000. And since then, we had permanently 3 to 6 astronauts in orbit. I heard that recently an Indian astronaut visited the space station. In parallel, there is also the Chinese space station, of course, and we have now in orbit several humans living in space. But I would like to come back on the station, because as I said, it has been deployed since 25 years ago. And in fact, it's a project which has been very hard in the making, and perhaps more political than industrial. I can remember when I was a young space attaché at the Ministry of Industry in the 80s, Europe was supposed to be a partner of the Freedom Space Station developed by the US, and then there was the fall of the USSR, and in fact the Freedom Space Station, which was supposed to be against Soviet Union, welcomed the Soviet Union and became the International Space Station. And so it has been a kind of testimony of the collapse of the Soviet Union. And so it has been, during all these years, the start of a political and scientific project whose main aim was to show to previous adversaries that they can work together for peaceful purposes. And I am sure that you are quite interested in this station, because in this station we had permanently beautiful pictures of what is going on in space, with astronauts walking in space, with small satellites being deployed, with some experience and so on. But there is a point which is, in my opinion, probably a pity, but it is the reality, is that the station had big technological ambitions, but 25 after the first launch, it is unfortunate to notice that we had just a few industrial results. Because, in fact, the station, it has been developed as a political project, and as a result, the station's industrial and commercial potential has never really been very developed. And why it was initially envisioned that production units would be installed for materials or medicines, in fact, this never came to fruition, because the station partners' priorities are elsewhere, and probably because the groundwork hadn't been laid. I remember that in the early days of the station, some people were fascinated by some molecules for drugs which could be developed in zero gravity, the growth of some crystals and so on, and it was very, very promising, and a lot of big industrial group was interested in that, but 25 years after the deployment of the station, we do not see so many industrial results. In addition, during the last years, the station has been, of course, hampered by the space shuttle disasters, and more recently, the issues with Russia. But I would say that in spite of these difficulties, the station is a huge success. Because first, people learn how to work in orbit and how to go into orbit. And so we have launches, both in the US, both in Russia, of rockets with astronauts, and we learn how to send people in space safely and so on. People, they stay in the station, they learn how to work in orbit, but probably I would say that the most interesting result of the station today is that many people everywhere in the world learned to work together. And in the beginning, the early partners of the station have been the US, Russia, Europe, Canada, and Japan. But now we have a lot of people who visited the station, and a lot of countries are de facto part of the station. And in my opinion, it's very, very important because, in particular, all the youngsters in all these countries are very often fascinated by space, and when you have a flight of an astronaut, afterwards, many youngsters, and when I say many, it's thousands, hundreds of thousands youngsters, and probably in India, a million of youngsters, they want to go to space, they want to become an astronaut, because they dream about people from their countries who went into the station. And so, this is definitely an outcome of the station. But if we look at the figures, it is not so simple because we had a very low return on investment. The cost of the station has been about 100 billion US dollars, which have been invested. And if we look at financial results, the return is quite low. But we have definitely this heritage and space, because of the station, became a part of the usual life, and I do repeat, everywhere in the world, and this is, in my opinion, very, very important. And so now we have this station. It has been launched 25 years ago. It is close to the end because it will continue to last, let us say, 5 or perhaps 10 years, but not so much. And now the next step is definitely about the moon. And why is it about the moon? Probably because the moon, it is quite easy. You know that 12 US astronauts walked on the moon in the year 1972. The moon is not very far. It takes 3-4 days to go to the moon. You can land on the moon, and it's a project which can be done and which can be redone because it has been done in the end of the 60s, early 70s. But the idea is now to have this project not to visit the moon for a few hours or a few days, but to stay on the moon. It's, in my opinion, the same difference as the first flight of an astronaut, Yuri Gagarin, in 1961. He stayed less than 2 hours in space, and now the station where 6 astronauts are permanently in space. And for the moon, it is the same. We had the first astronauts in the 60s, 70s. They spent a few hours on the moon, and now the idea is to find a way to have a permanent settlement on the moon, and this is a project which is under study, under development, and which, in my opinion, is absolutely foundational for human space exploration. And you probably know, because India is a part of this project, that the US, with partners, has engaged the Artemis project to return to the moon, but not to go there, but to establish a permanent presence. And this project is now under development. It is developed around the Gateway cislunar outpost. As I said, there are more than 50 nations on board. Most of the people who flew on astronauts are now a part of Artemis, and it is the next chapter, after having someone in space, having someone on the moon. And the project is under development with an approach which is totally different from the approach which was taken in the 60s, where the NASA was in charge of the project. Today, the NASA and all its partners will rely upon private companies, and in particular for the moon. Today, NASA contracted with SpaceX, with Starship, and Blue Origin with Blue Moon, but I am sure that there will be other companies. And so the idea is to have these companies launching the hardware, allowing to people, perhaps as in the station, to stay permanently in the moon. And I told you earlier, then, the station is a fantastic project, but unfortunately, we do not have all the results we could expect, in particular in the field of industrial results. And this is why I think that for the moon, we must now open the discussion to have real industrial applications. And you see on this slide that there are many projects. Here you have a project, I will come back in detail later, with solar arrays to create energy and so on. But we must definitely work today to have real industrial applications. And in my opinion, this will be possible. Why? Because people of my age, there are not so many people as me in the audience, but you probably know that the moon missions in the Apollo era, there was a small vehicle, a so-called LEM, allowing to put 2 astronauts for a few hours on the moon. Now the landers which are under study are much bigger, and so they will be able to support a genuine industrial infrastructure on the moon. And in particular, there could make it possible to build lunar industrial facilities operated, of course, by astronauts, operated by artificial intelligence. We spoke a lot this morning about artificial intelligence, but to study the moon, it's absolutely fundamental. I would like just to give you an example. The 12 astronauts who went to the moon, they brought back a lot of stones, a lot of samples taken on the moon. Unfortunately, most of these samples have no value because they are not so much interesting. And the last astronaut, so-called Harrison Schmitt, he was a geologist. And so the samples he brought back are absolutely fantastic because he took the right sample because he knew perfectly the right rocks and the wrong rocks. And so for the future, we probably do not need another geologist, but artificial intelligence allowing to decide what is interesting and what is not interesting. And I am sure that for the exploration, artificial intelligence will be absolutely fundamental. And the objective will be to bring products extracted, transformed, or manufactured on the moon back to Earth and to apply them for space exploration missions, which in the future could go beyond the moon. Of course, a lot of people speak about the Mars mission, but in my opinion, it is not for tomorrow, because tomorrow is the moon. Mars, it will be later. I told you that the moon is quite convenient because you have a 3-day journey. To go to Mars, in total, you have a 2-year journey, and it's totally different. But so, we will have this capability to develop a real industrial application on the moon. This is the new approach, which is different of this V1, which has been developed in the 60s. And I think that the lunar environment holds a very great potential. Why? Because when you are on the moon, you are in the vacuum of space. It means no atmosphere, and it is ideal for fabricating ultra-pure materials. We have also a very weak gravity. On the moon, you have about 1/6 of the Earth gravity, so it means that if on the Earth you feel that you are 60 kilo, on the moon you are 10 kilo, you think that you are very, very light, but the mass is the same, but what you feel is not the same. And so it will make the life of an astronaut much easier than on the space station, because on the space station you have zero gravity, and you see on the video that it is not so easy. One gravity which is 1/6 of the Earth gravity is perfect, because you don't have the Earth gravity and you don't have the difficulties linked to the Earth gravity, but you don't have the difficulties linked to zero gravity. So the moon is an excellent environment, and in addition, the lunar surface abounds with rare materials that could be brought back to Earth or used to produce a fuel for missions here on the moon. So you see that there are huge potential on the moon, and because we have such a huge potential, and to not do what has been done with the station or what not has been done, we need now to address an upstream market. Because I am deeply convinced that the success of such industrial enterprises hinges on the need to create a market at the earliest stages of the project. And that means that we must define what activities we intend to pursue from the word go So we are ready to start them from the very first flights and involved in defining lunar missions. Today, the satellite launch market is totally established. If you want to launch a satellite, there are launch services providers. My former company, Arianespace, is one of the best launch services providers worldwide. There are other launch services providers. We have also a flourishing satellite applications market, but today it is clear that the lunar economy is still to be invented, and this is, in my opinion, what is at stake now if we want to prepare for the exploration of the moon and for exploitation of lunar resources. And I would like that you keep in mind this point, lunar economy. Lunar economy today seems to be very futuristic, not very realistic and so on, but launching satellites today is a reality. Application for space, and in particular here in India, I've always been fascinated by the applications developed by ISRO, in particular for farmers. This morning, Prime Minister spoke about precision farming, which is possible due to the satellites, and so it is existing, but lunar economy today, it doesn't exist. And it is exactly what we have to do and what we have to invent in the coming years. Because I think that developing a lunar economy and exploiting the lunar resources will be a formidable engine for driving technology development. And why? Because exploiting lunar resources will be something totally new. And I think that there are 6 fields which are quite interesting, and I'm going to come back on these fields. The first one, we are going to build a lunar infrastructure, and for that, of course, we will need energy. And so it means that we will have to produce energy on the moon. We will have also to have materials. We cannot bring energy from the Earth to the moon. We have to produce it in situ, and for the materials, it is the same. We have to take the materials existing in the moon, transforming them, but you need materials. We need also transportation. You probably remember that in the Apollo missions, starting in Apollo 15, the fourth mission, the astronauts, they had a small jeep, and they went at several kilometers from their spacecraft, and when we will have a colony living on the moon, we will need transportation. We will have also to take advantage of the lunar environments, and I spoke about its unique characteristics for the development of components, biotechnologies, and also to make science, because science on the moon will be fantastic. And now I would like to come back to this point. The first one is about energy. And we will have to identify sources of energy on the moon and the methods to extract them, and it will be probably the most important issue, because we will have to meet the energy requirements of building, operating, sustaining, and using a lunar base. We will have to locate, extract, produce, and store fuel for launchers and spacecraft returning to Earth and departing perhaps one day for other destinations as Mars. And we will have to develop original methods and techniques for extracting, for managing energy that can be used on Earth to generate it at lower cost. And this is quite important, because I am sure that when we will have learned to develop energy and to extract energy on the moon, we will have also benefits on the ground, as sometimes we have on the ground benefits of what is done today on the space station, but here for the energy, it will be made on the moon. The second point, which is also very interesting, is about materials, because the construction of a lunar base will require the development and the fabrication of innovative materials which can be used probably for other applications. And this implies to make an inventory of what is feasible on the basis of what we can ferry to, install and use on the moon, and what we can extract, produce and apply there. I am sure that at the beginning we will build the lunar base with materials coming from the Earth, but very quickly we will start to use materials on the moon, transforming them and using them to build the lunar base. We will have to use these materials to build the base, as I said, its logistics, and to ensure it is designed, developed, and optimized for this purpose. And last but not least, as for the energy, I am sure that studying how developments on the moon must be adapted to using these materials on Earth. Once again, we will have on Earth benefits of what we will do for materials in the moon. The third point, which is very important, is about transportation. And here you have a futuristic vehicle, let us say, but a lot of car makers are very, very enthusiastic to be the first one to put a car on the moon. One of these car makers told me, and at the level of the CEO, I don't really understand what you want to do, but I can tell you that if my company puts the first car on the moon, it will be much better than being the winner of very famous car races. And it is clear that the day you will have a car made in India on the moon, it will be a fantastic marketing for the car on the Earth. And so we will have to develop this, transportation means with safe, autonomous systems for transporting people, transporting energy, transporting materials. And so, at the beginning, as for the rest, we will start with vehicles manufactured on Earth, and they will be operated on the moon. But the next stage will be to start building these vehicles from lunar resources on the basis of all the experience and the lessons we will learn when being on the moon. And in the same time, we will also need to build an infrastructure to operate these vehicles. Probably there will be on the moon some gas stations or some places where to reload if we have electric vehicles and so on, but we will have an infrastructure to develop. So you see that these 3 points, energy, materials and transportations, are absolutely fundamental if we want to stay and to live properly on the moon. Now, using the lunar environment, it will be also very, very exciting. And I spoke about the components because it is clear that the lunar environment should prove very, very conducive for fabricating components, whether for systems built on the moon or for sending them back to the Earth. It is clear that lunar minerals contain precious rare materials for developing, for fabricating components on the moon. I spoke about the low gravity of the moon, the ultra-vacuum conditions. They are impossible to replicate on Earth, and they will be obtainable at lower cost to boost component fabrications. And in a nutshell, such made-on-the-moon components will benefit from the latest advances in artificial intelligence, and it will accelerate its uptake. So you see that components, it will be something very, very interesting to produce on the moon. The same for biotechnologies. Why for biotechnologies? Because up to now, in fact, medicine has been largely used for space. Because when you put astronauts in space, you use all what you know in the field of medicine to be sure that the astronauts will be okay. Now the idea is to reverse this paradigm, because we, in fact, I am sure that being on the moon will bring benefits for medicine. The lunar environment, for instance, will enable work made on the space station to understand how pathologies originate to be continued. For instance, you have something which eats all the people when you become old, which is osteoporosis. So it means that your bones are becoming more fragile. And when you are getting old on the earth, osteoporosis is a disease, and your bones are becoming weaker and weaker. When you're in space, they become weak, but when you come back on Earth, they become strong. So it is reversible. And I am sure that this kind of studies can be done also on the moon, and it will definitely be something quite interesting. We will have also the preparation of very long duration space exploration missions. Today we have an experience of 6 months in the station. Some astronauts stayed 1 year, but it is a maximum. If one day we want to go to Mars, it will take 2.5 years, and so the moon will be the perfect field to learn how to stay a long time in space. So I spoke about components, biotechs, and the last point, and probably the most exciting, because as it has been said, I am basically a scientist. I started my career as an astronomer, and performing science on the moon is probably the ultimate for science. And why? Because the moon, with its weak gravity, ultra-vacuum environment and distance from Earth, the moon offers unique conditions for both optical and radio frequency observations. It will be possible to install very large observatories on the lunar surface to monitor, mitigate, and control climate change on Earth. From the far side of the moon, we'll be able to observe the universe free from the obscuring effects of human-induced pollution, particularly for radio frequency observations. And last but not least, the study of the moon, its surface seismology, will also deliver precious insights into the origins of Earth. So you see that these 6 ideas, I started with energy, materials, transportation, components, biotechs, and science are 6 excellent reasons to go back to the moon and to stay on the moon. But in addition to these ideas, which are, let us say, standard space business, I think that staying on the moon and having a moon infrastructure is also a chance for non-space industries. Because all what I said, of course, deal with standard space industries, people who develop launch vehicles, satellites, a space station, and so on. But I am sure that now, and is the next step of my presentation, we must develop the use of the moon for non-space industries. And I think that it is possible, because everywhere in the world, there is a very close interest in the space adventures. Politicians, they speak about space, everyone speaks about space, because it's an adventure. When you send someone in space, it's something which is totally new, and people want to be involved in this space adventure. And I remember that during all my career, I had the visit of people working in non-space industry telling me, but can we do something, because we would be very interested to be in the moon. For instance, recently someone who exploited a huge fleet of very big ships carrying containers, he told me, but I would like to put a container with my trademark on the moon, because it will be a fantastic marketing, and we ferry containers everywhere on the Earth. The next chapter, the next frontier is the moon. So it is time, in my opinion, to attract non-space industry, because all these people, they are interested, and we have just to develop the responses that they want to hear. We will be on the sidelines for infrastructures, because this equation is a hard one to resolve. As for structural reasons, non-space industries today have only a supporting role in developing this lunar infrastructure, but given the project's economic size and scale, I spoke about 100 million for the space station, and probably the moon will be the same order of magnitude. I think that we need to broadly rethink this role, as industry cannot afford not to be involved, and above all, I am sure that the project will be the loser where it is to be pursued by the space industry alone. So it will be a win-win situation if we bring the non-space industry. It will be a winning situation for non-space industry, but also for space industry, because this project will be strengthened. It will be an opportunity to develop a technological excellence, because this is especially the case now that many of today's non-space technologies are vital to develop a lunar infrastructure and, above all, to harness its full potentials. Biotechnologies, novel materials, electronic chips, and of course, artificial intelligence, once again, all deserve a special mention in this regard, in a geopolitical landscape where competition is increasingly fierce and can only benefit from the spin-offs of this program. Last but not least, I am convinced that there is an abundant capital and market size, because there is an abundance of available capital for projects where sovereignty, high-tech intersect, and it will be the case for industrializing the moon. Non-space industries also represent a large market offering multiple possibilities, both at commercial and consumer level, to use this lunar infrastructure and thus to ensure the success of its project. So you see, I don't want to be longer, but I hope that I convince you that going back to the moon, to stay on the moon, is very interesting, and that it is feasible, and it is feasible if we bring with us non-space industry, because the moon is probably the new frontier for high technology. I do not say that we are going to send thousands of people on the moon, but in my opinion, at the beginning and during a few years, it will be on the moon, a kind of international space station on the moon, as we have today an international space station at 400 kilometers over our heads. But this time it will be on the moon. And with the station, we didn't take on board non-space industries, and this time we must take on board the space industry. To conclude, I would like to come back to my introduction. I told you that I have a long experience of the cooperation with India, and I am sure that this project of going back to the moon could be an excellent opportunity for Europe-India cooperation. Thank you. I think that Europe, in this new landscape, will more than ever be a key partner for India. We established many partnerships with India in the past. We had recently a conference here in New Delhi of the International Astronautical Federation, GLEX, and an agreement has been signed between Europe and India. And we have, in fact, programs which are, by many extents, similar. But to develop such a cooperation, I think that we need a very careful preparation, because Europe is complex. We have a lot of entities, a lot of bodies, both at the level of Europe, at the level of national entities. We have big companies, we have startups, and so on and so on. But it's a demonstration and that Europe is very vibrant for space exploration. In India, it is the same, and very soon, India will become the first nation to send astronauts independently into space. I'm very impressed by your project Gaganyaan, and it's only the beginning of India's human spaceflight adventure, and in the same time, the European space industry is developing also human spaceflight capabilities, and so I think that we have globally the same approaches, and this project, at the level of agencies, in my opinion, it will also link space economies, and I am sure that a joint Europe-India effort in this field could afford numerous advantages and achieving the goal of independence in launch vehicles and human spaceflight will in turn boost commercial competitiveness. Now, I would like to say a few words in conclusion before answering to your questions. The first point, of course, it is that going back to the moon is definitely the next chapter in space exploration. And since both India and Europe put space exploration at the top of their agendas, I think that trying a way to do this space exploration together is probably the best way to prepare for the future. The last point about Europe-India cooperation, we have the same approach in Europe as in India for exploration. And I am sure that after having launched satellites together, having developed satellites together, having developed applications together, going back to the moon to develop non-space industry and new applications will be definitely the next chapter of our common history. Thank you.
Thank you, Dr. Gall. It's very interesting. I'll just will try to sum up that. Going back to the moon, very nicely talked about the importance of why the interest in going back to the moon and exploration. Actually, if I summarize the talk in a minute or something, he talked about the transportation system that we have to look at, the economy. So a lot of things are tried out. So we are still reaching what is the optimized way of going to the moon, how to get transported. And the astronauts' experience has to be taken into account for an appropriate habitation that has to be planned at moon. So there is a huge potential, there is no doubt about it because of the minerals and the other aspects. So how do we go about the manufacturing on the moon, and what kind of decision we have to do, and how do we decide on this to go about. And there are 6 areas was touched upon, like energy. How do we create energy at that place, because that's one of the fundamental requirement, and the materials that is available on moon to create this, and the transportation and the habitation. Especially it is one of the very good domain for the non-space industries to come and venture into this kind of system, so that the technology that we are going to use in moon can be useful in Earth also, so that it can become a very useful in using the resources of Earth also. That's my view. And there is an abundant capital and capabilities of using it as a base station on the moon, so that further we can explore the other nearby planets and celestial bodies in economical, like a ground segment. We can look at the space, the moon as a ground station or the base station for going on many things, so that it becomes an habitat. And nicely touched upon the cooperation that is required, very eloquently talked about the way we can start producing some technology on moon, which can be made use of some of the materials and minerals that is available on moon. So in a whole, it's a very wonderful lecture based on all the experience that you had throughout the world, and we thank you for enlightening this audience on this explorations. Thank you. Now we'll take 2 or 3 questions. Yeah, go ahead, Mittalji.
So can I hear?
Okay. You come forward. No, wait. Go ahead.
Can I'm ECG.
Hello.
Hello, can you hear me, sir?
Yeah, so
Can I speak
yeah,
quickly?
now I think I can speak. So I'm PC Jain, scientist from DRDO. With the application of artificial intelligence, international collaboration, and the private participation, now the space exploration activities are expedited quite good. So what is your view whether with this much collaboration, whether the space tourism will be reality in near future for the common man? Can you, and in what timeline do you see? Thank you.
As I said, there is this project to go back to the moon, the Artemis project, with a lot of international cooperation. But my point is that this project will exist, but we must work in advance to prepare the use of this infrastructure which will be deployed. And we don't have to make, I don't know if we can say it's a failure, but the same approach as the space station, because the space station, I do repeat, we have $100 billion in orbit with return on investment, which is very weak. And I am sure that on the moon, if we prepare the exploitation of this infrastructure well in advance and in associating non-space industries, we will have a huge return on investment. And I am sure that for the space station, it was a project 99% for the space industry. I am sure that on the moon, it will be a project for space industry to deploy the infrastructure, but it will be mostly a project for non-space industry to use the infrastructure. This is the biggest difference, and this is the way we have to pursue now.
Can I ask the next question?
Yeah.
Yes, here.
No. Please go ahead.
Here, sir, here, to the left, or to your right, sir. Here.
Go ahead.
My question is slightly different. Of course, while we all, look forward to the, the space and the kind of steps that scientists are taking, and of course, both India and the global, the European, everywhere. My question is slightly different. My concern is, I think everybody's concern, with people owning land on moon, and both the private and entities owning large spaces. How do you see, what are the political implications of this kind of commerce happening in space, and what are the advantages and disadvantages of this particular scheme? If I'm just asking from a layperson's point of view. Thank you.
No,
Okay. You want to take that question?
Yes, I do fully agree. There is a real question about, for lawyers, let us say, but there was the same question with the space station, and we found a solution. So I am sure that when the project will start, we will find a solution, and associating government entities and private entities. But today, in space, there are a lot of private entities which are coming. Here in India, it's a good example with all the startups you develop, the private industry and so on, and it's a part of the landscape, but I am sure that we will find solutions.
Okay. Last question.
Thank you, sir. Thanks for the informative presentation made by you. Just have one question. This is regarding the planetary policies, planetary protection policies basically. What's your opinion on the planetary protection policy, especially from the microbial contamination point of view? And how practical is it to implement, especially the
Just ask one question.
Yeah. What is your opinion on planetary protection policy,
Okay.
especially with respect to microbial protections?
No, I think that it's a part of the game. We have to do it. We have to develop this project, keeping in mind that we have to protect the moon as we start to protect planet Earth. On planet Earth, there were difficulties which are a consequence of the human activity as climate change and so on, pollution, but now people work differently, and for the moon, since the beginning, we will have to be sure that we will not create difficulties on the moon.
Okay. Last question. Mithun.
Can
Wait. Please.
just,
No, please wait. Last question I told him.
Yeah, thank you very much for this fascinating talk. You pointed on the energy. What would be a possible candidate for viable energy at the moon? Are there any thoughts?
I think that what is probably the first approach, the most simple, will be to use solar arrays. After that, there will be probably some other sources of energy. But energy is very important and very promising. Me, I consider through my experience in the field of technology that the driver of the progress of technology worldwide has been the progress in the batteries. You see, 20 years ago, the batteries would never allowed to have all the smartphones that all of us we have in our pockets. The same for the cars and so on and so on. So energy battery, it's really a hot topic, and I am sure that the moon exploration will benefit of the developments which will be made. I think that probably we will have what I would call clean energy, probably not nuclear energy on the moon because of the risk, but solar arrays is a good thing. If we can manufacture on the moon, extract hydrogen, it could be also a source of energy and so on. But we have to work on that. But it is clear that it is a crucial point.
Thank you. You can ask him privately, okay? There is point of time. Kindly excuse. You can ask later. Thank you. Thank you, Dr. Gall, for your time. And so with this we are ending this session. Please, I am handing over to them. Thank you.
So with this, I would request the chair of the session to felicitate Dr. Gall for his insightful, wonderful talk. Before I propose the formal vote of thanks, I would like to make an announcement. All the participants should move towards the parking area near hall number 14, and from there the buses will go to their respective hotels, and you are supposed to come by 8:45 tomorrow morning and be seated in the hall, and kindly bring your badges for the hassle-free entry into the Bharat Mandapam. And with this, I would like to thank Dr. Gall and the session chair, Dr. A. Rajarajan, for chairing the session. Thank you very much. See you tomorrow.